Memory is the storage component of an information system, and it is used to keep data ready for the system to use when needed. Aside from the read-only memory and the random access memory, another type of memory is used, which is the registers. These are used to load the data required by the arithmetic logical unit to process instructions, and they are part of the ALU itself, allowing for optimal processing speeds. In order for a processor to know where the data that it needs is located, it has to follow some form of memory addressing. There are 5 common types of memory addressing, which are the following. Register addressing directly points to the addresses of the registers that the CPU wants to access. Immediate addressing is the use of data specified directly to the CPU to use, such as a specific number. Direct addressing is when the CPU is pointed to a memory address where the data is stored. Indirect addressing is where the address used contains information about another address where the data is stored. Finally, base offset addressing is when the CPU adds an offset number to the address it is given, in order to reach the real address where the data is stored. In addition to the main memory used by the information system, secondary memory storage is available, such as magnetic, optical, and flash media. Examples of secondary memory include hard disks, DVDs, and magnetic tapes. This media is usually inexpensive, and is capable of storing large amounts of data. However, when the CPU wants to access this data, the operating system has to read it and then it has to move it to real memory. The operating system can use a portion of secondary memory as virtual memory and make it act like real memory, and this is normally referred to as page file. The concept behind this is to allow the system to move data that is occupying real memory but hasn't been used recently to secondary memory, in order to free up resources. The drawback of this process is that when the system needs to access the moved data, it will take a longer time to retrieve it from secondary memory, and eventually slows down. There are several security issues that are related to memory. Since sensitive data is stored on the systems, it is essential that any media that is going to be disposed should be fully wiped. Data access is another security issue, so organizations should have full control over who can access the data that is stored, processed, or transmitted. This includes managing data access within the system itself, where a process's data should not be accessible by other processes that don't require it, and this is usually referred to as process isolation. Having security levels in place, especially for systems that allow multi-level security, requires that adequate security controls are implemented to prevent unauthorized data access, leakage, or damage.